This is the code for our RFID and passcode smart lock. We had to include certain libraries such as wire.h, SPI.h for serial communication. This MFRC 522 library is used for the RFID. This Keypad library was used for the keypad that we were using, and this is the library that was used to interface ESP32 servo with ESP32 on this Arduino IDE. What we did was we defined the servo pin, the PWM pin of the servo motor, initialized an instance of servo motor. Then we defined the serial SS pin of the RFID and the reset pin of RFID, created an instance of RFID as well. Then we gave it a map of the keypad that we had, and we gave it the password that we will make. So our password for our project was 296. So this is where we gave it the password, and then we defined the pins for the rows and columns that we had initialized and connected, and this is where we've completed and initialized the keypad for our project. In the setup, we set up a baud rate of 9600. Began SPI for communication. Initialized the RFID module to start reading RFIDs. We attached the servo motor and wrote 0, which meant that it will be in the start position when the project is powered on, and the first time it asks us to scan the card or enter the password. What happens in the loop is that the keypad gives the pressed key to this variable key, and if there's a key pressed, it shows what key was pressed, increases the increment because there has to be 3 inputs 3 times. The button has to be pressed 3 times for it to count as a password and then checked against our given password. Here's that condition. So if k is 3 and it matches given password above, which was 296, it grants access, which is access, and prints the message access granted. It calls this function grant access, which we'll show at the end. After that, it again initializes I and k, and then shows the output on the monitor to either scan or enter the password. This code here is for the RFID. So this shows that if this keeps on looking for a card that has been placed on the RFID, if there has been a card that placed on the RFID. And when there's a card placed on the RFID, it selects that card, it gets the card's UID, it prints that UID, it then stores the content in this content, and then we start this loop. In this loop, we're converting the UID into hex, so it's easier for us into hexacode, so it's easier for us to check whether it's a valid RFID or not. This is the entire code for the hex conversion. And then we come here and then we check if the given RFID is corresponding to the valid RFIDs for our system. For example, we were 4 in our group, so we all had our different RFID cards. So whenever one of our these were the corresponding UIDs for our RFID cards. So whenever one of us tapped the card, if it matched one of these 4, it would as you saw at the start, the servo motor would open and it would show on the serial monitor the name of the person and like welcome. And otherwise, if either were not, the UID given was not one of these, it would go to this function, which is deny access. The functions are here. This grant access would come here with the parameter message. It would print the message. It would make the motor rotate 90 degrees, stop for 5 seconds, and then go back to its initial position. And if it's a deny access, then it would just show on the monitor denied and then delay 3 seconds. So you must be wondering how we got these different UIDs for our RFID cards. So what we did was we went to the examples and in this library they've given us an example code called dump info. So what dump info does is dump info has the entire code already placed in this file, and whenever we run this program and we scan a card, it gives us everything required for to everything about that RFID, which we can use then to verify and then make the smart work, and then get these values and then make the smart work like we've made. So this is our project smart lock using RFID and passcode, and we've shown you the functionality of it at the start. Thank you.